Hi, I'm Teacher Johanny, and let us begin our online math class. Our lesson for today is Common Monomial Factoring. But what is common monomial factoring? It is factoring a polynomial containing a common monomial factor. Factoring is about finding the factored form. Hence, the factored form is the final solution or answer in any factoring problem. Common monomial factoring is simply made up of two factors, the GCMF and the quotient. But what is GCMF? GCMF is the first factor in CMF or common monomial factoring. A GCMF is the GCF of a polynomial. It stands for greatest common monomial factor. Now what is quotient? A quotient is the second factor in CMF factoring. It is a polynomial expression which results when the original polynomial is divided by the GCMF. Let's examine this problem more closely. 4x squared is the GCMF in our example. It is actually the GCF. Why? Because the number 4 is the GCF of the numbers 12, 36, 40, and -8. While x squared is the GCF of the variables x to the 5th, x to the 4th, x to the 3rd, and x squared y. Combining 4 and x squared together by multiplication, it will form 4x squared. Thus, 4x squared becomes the GCF of the given polynomial, or otherwise known as the GCMF, or the greatest common monomial factor. What about the quotient? The quotient is the result of dividing the original polynomial by the GCMF. For instance, let us divide the numbers. 12 divided by 4 is 3. 36 divided by 4 is 9. 40 divided by 4 is 10. And -8 divided by 4 is -2. Next, we divide the variables. Division is like subtracting or cancelling. Let me show you. X to the 5th divided by x squared is like cancelling two x values from 5x values. Thus, only 3x values will remain, or x to the 3rd. It is also like subtracting, that is, by subtracting their exponents such as x to the 5th minus 2, hence, we will get the same answer as x to the 3rd. Continue along that line. By dividing x to the 4th by x squared, 2x values will remain, or x squared. Or it could also be done by subtracting the exponents such as x to the 4th minus 2, which also gives x squared. Dividing x to the 3rd by x squared is cancelling 2x values from 3x values. Thus, only one x value will remain. Finally, dividing x squared y by x squared is like canceling x squared from x squared y. Thus, only y will remain. To find the factored form in CMF factoring, we will be using the quickest method possible. Factor the numbers using division by prime numbers only, or the 2, 3, 5, 7, 11 rule, and via continuous division. Divide the numbers only by prime factors from the list of prime numbers. Dividing by prime numbers minimizes the difficult task of guessing or thinking about what the next common factor or divisor would be for the numbers, since in the list of prime numbers, surely you will be able to find a number divisor without hassle. Remember the 2, 3, 5, 7, 11 rule? Begin your search for a possible divisor starting from the lowest prime divisor, which is prime number 2. Are the numbers 12, 36, 40, and -8 divisible by prime number 2? Since all are even numbers, we can divide all these numbers by 2. Write 2 as the first number divisor. Next step is to find a possible divisor for the variables. Remember that finding a variable divisor is a one-time event and is only done once, and at the beginning. What is the GCF of the variables x to the 5th, x to the 4th, x to the 3rd, and x squared y? Just follow these steps. First, list all the variables that you can find without writing the exponents. We shall find x, and also y. But only variable x is common to all the monomial terms. Variable y isn't common or present for all the terms. Therefore, we cancel or eliminate y. Since only the variable x remains, the final step is to find an exponent for the remaining variable x. To find the GCF of variables, we will use this technique called the least exponent method. That is, by choosing the variable with the lowest exponent from among similar variables like variable x, we shall easily find the GCF of variable expressions. Therefore, x squared has the lowest exponent among x to the 5th, x to the 4th, x to the 3rd, and x squared. Therefore, x squared is the GCF of the variable x. At the same time, x squared is the variable GCF, and hence the variable divisor for the whole original polynomial expression. Once again, it is called finding the GCF of variable expressions via the least exponent method. Hence, x squared is the GCF of the variables as well as the variable divisor. Joining the number divisor 2 with the variable divisor x squared, that gives us 2x squared as the first complete divisor. We can now proceed with the division process. By dividing 12 by 2, we get 6. Remember, division of variables is like canceling or subtracting. X to the fifth divided by x squared is like canceling x squared from x to the fifth. Thus, x to the third will remain. It's also done by subtracting exponents 5 minus 2 to give us 3. Next, dividing 36 by 2 gives us 18. X to the fourth divided by x squared cancels x squared from x to the fourth. Thus, x squared will remain. It's like subtracting exponents 4 minus 2 to give us 2. Next, divide 40 by 2 and we shall have 20. Divide x to the third by x squared, then we are left with only one x value. It's like subtracting the exponents 3 minus 2 to give us 1. Or we can simply rewrite it as x. Next is to divide negative 8 by 2, which gives us negative 4. Dividing x squared y by x squared cancels x squared from x squared y, leaving us with no x value or x raised to 0, and the variable y. It's like subtracting the exponents 2 minus 2 to give us 0. We can simply rewrite the variables as y. Next, we continue with the division process, moving one lower level down. Continue from our list of prime numbers above. Can prime number 2 still divide the remaining numbers 6, 18, 20, and negative 4? Yes, we still can. Therefore, we continue to use prime number 2 as prime divisor. Write 2 at the divisor portion at the left. At the second level, remember that we don't need to find another variable divisor because it was a one-time event and we did it already earlier. We simply continue to find divisors only for the numbers. Let us resume division. Divide 6x cubed by 2 and we shall have 3x cubed. Divide 18x squared by 2 and that gives us 9x squared. Divide 20x by 2 and we get 10x. Divide negative 4y by 2 and we shall have negative 2y. Now that we are done with the second level, we shall continue the process by going one more level down. Can we still divide 3, 9, 10, and negative 2 by prime number 2? Not anymore. How about by prime number 3? The numbers 10 and negative 2 are not divisible by 3. By close inspection, we are left with no more number that can further divide the remaining numbers. Therefore, we have to end the division process. Now, it's time to determine the factored form. Remember, in CMF factoring, we have to consider two factors. The first factor is the GCMF, or the greatest common monomial factor. The second factor is what we call as the quotient. To find the GCMF, let's get back to what have been our divisors so far. That would be 2x squared and 2. By multiplying divisors 2x squared and 2, this will give us the GCMF, which is 4x squared. The final procedure is to find the second factor or quotient. Search the bottom area. Notice that by enclosing this last expression with parentheses, we have just found the quotient that we are looking for. Writing the GCMF and the quotient together, like in multiplication, we shall have the final answer or the factored form. The factored form is the final solution to any problem in factoring. Thus, factoring the original polynomial by CMF, or common monomial factoring, will give us the final answer, which is the factored form, or GCMF times the quotient, or 4x squared times the quantity of 3x cubed plus 9x squared plus 10x minus 2y. Congratulations! Thank you for watching. I'm Teacher Johanny. Don't forget to like this video. And if you're new to this channel, just click the subscribe button and tap the bell button to get timely notifications so you won't be missing out future lessons.